So a lot of the functions we've done before with real numbers, we're going to do with complex numbers. So the idea of solving quadratic equations is one. Before we do that, what we want to do is just make sure we can clear up something. And that's in this sec. If we've got two complex numbers, a plus ib and c plus id are equal. Now, this is pretty logical. If they're going to be equal, then the real parts must be equal, and the imaginary parts would have to be equal. Now, you're probably going, well, duh. Yeah, it really is that. But that's one of these are all syllabus notes, and we have to make sure we recognize that situation. And that will occur any time. Two complex numbers are equal, the real parts must be equal, the imaginary parts must be equal. So keep that in mind as we go through and solve some problems here. So what we want to look at here is solving quadratic equations. How do we solve a quadratic equation? Our most simplified way of doing that is to factorize. Unfortunately, because a lot of these ones are going to give us complex solutions, we're really going to have to just go back to completing the square or the quadratic formula, whichever one you want to use, because it's not going to be able to factorize. If you can see the solutions to this one, minus 1 plus or minus I times root 6, that's not one you're going to pick out as roots nicely to factorize there and get down to this bracket. So we're really looking at the situation, and also you look at here, this situation is going to give us a situation where our quadratic would give us a negative number under the square root. So it's not going to be able to factorize nicely. So I've done completing the square method here to complete this one. So take your 7 across, complete the square, and to get x plus 1 all squared equal to minus 6. So normally what we'd find in courses done previously, we'd stop at that point and say, well, no real solutions. But there are complex solutions. Every quadratic equation, we can say every quadratic equation has two solutions now. Sometimes those solutions will be equal, but we've had that before, so one solution. But it's got a solution every time. There's no situations where we don't have solutions to a quadratic equation. So this one, we just take the square root of minus 6, which is the same as writing I root 6, because we could write minus root 6 as root 6 times square root of minus 1, which is I. So that's where the I root 6 comes in. We'd subtract our 1 on both sides, and there's our two solutions, and that's what our brackets would look like when we factorize it. Okay, so you can see you're not getting a nice factorization. So it's going to look like that. What we're seeing as well here is one of the results that we'll talk about a lot more later on, is that if our equation that we're solving has real coefficients, so whether it's a quadratic or a cubic or something of a higher order, our factors will always occur. Our roots of the equation will always occur in complex conjugate pairs. So that's something we'll talk about a lot more, but notice that as we're going through and solving these quadratic equations. So again, here's another example, x squared minus 3x plus 7. Again, I've completed the square. You could solve it using the quadratic formula. If you want to use the quadratic formula, go ahead. That's not a problem. These are just done using the completing the square method. So taking the 7 across, adding the 9 on 4, which is 3 on 2 all squared, completing that square, taking the square root. So square root of 19 minus 19 would give us I root 19 over the 2, square root of 4 is 2, and there's our solutions there. Again, notice complex conjugate pairs. And again, here I've solved this one using the completing the square method. So take the 10 across, add the quarter, factorizes to x plus a half, take the square root of both sides, and then subtract the half there to give us those solutions. Done exactly the same way using the quadratic formula will give you those same solutions. It's up to you, it's not a problem. So keep that in mind about how can we solve quadratic equations. Well, it's not a problem now to have, we won't ever have a situation where we'll say no solutions to a quadratic equation.